right, there's three ways to write electron configurations: orbital diagrams, which we'll call boxes and arrows, standard notation, and noble gas configuration. We've already done orbital diagrams, which are the boxes and arrows, so let me do one example as a refresher, and it will also lead into the other types of electron configurations. So we're going to use calcium as our example here. Calcium has 20 electrons, so we need to find where they go. So we'll start filling up those orbitals in the order that's dictated by the periodic table. Starting always with the 1s, and S has one orbital, so we draw one box, and we can fit 2 electrons in there. 2 electrons down, we're going to keep going. We still have 18 electrons left to place. After the 1s is always the 2s, and we can fit 2 electrons in there. So there's 4, we still have 16 to go. Going across the periodic table, we hit the 2p next. P sublevels have 3 orbitals, so I'm going to draw 3 boxes, paying attention to the order in which I fill them. So we've got our 4 electrons. Here's our 5th, 6th, 7th, 8th, 9th, and 10th. Remember, you have to put 1 electron in each of those boxes before you go back and give it a partner. So that takes care of the first 10 electrons, and we still have 10 more to go. After the 2p is the 3s. The 3s still has 1 box, and we can fit 2 electrons in there. After the 3s is the 3p. That 3p, because it's a p, is going to have 3 boxes. There's our 13th, 14th, and 15th electron, and then 16, 17, and 18. Well, I only have 2 electrons left, and they're going to have to go into the next sublevel, which is the 4s. That 4s, 1 box, and there's our 19th and 20th electrons. Orbital diagrams, boxes and arrows. The next way to do this is what I'm going to call standard notation. This is going to be pretty easy because we don't have to draw any more boxes or any more arrows. All you're going to do is simply indicate how many electrons would be in that sublevel. For calcium again, I'm just going to say that we start with the 1s, and how many electrons can go in a 1s? 2 electrons. So all I'm going to do is put a 2 as a superscript next to that s. 2 electrons in there. The next orbital, the order never changes. We still follow the same order. 2s, and I'm going to put 2 electrons in there. No boxes, no arrows, just tell me how many electrons are in it. After the 2s is the 2p. Well, I've only placed 4 out of the 20 electrons. I'm going to be able to fill this p sublevel, so I'm going to put 6 electrons into the p. After the 2p is the 3s. That's also going to be completely filled with 2 electrons. After the 3s is the 3p. That 3p is going to be filled with its 6 electrons. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18. Again, 18 down. I still only have 2 left, and that goes into the 4s according to that filling order. After the 3p, I get to the 4s, and I have 2 electrons left, and that's the maximum number that can fit into this next sublevel. So here's what an electron configuration in standard notation looks like. No boxes, no arrows, just say how many electrons are in that particular sublevel. Another example that we can use to illustrate this point, we'll jump down and do platinum. Yeah, we'll use platinum. PT. Platinum has 78 electrons. And if we were going to write its electron configuration using orbital notation, we'd be here all day drawing boxes and arrows. Instead, all we're going to do is start with the 1s and work our way through those sublevels, filling each one up until I run out of electrons. When I run out, I'm done. So, following that order, 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p, 6, 4s2. This gets us all the way up to where we were with the calcium example. Calcium only had 20 electrons. Man, we still got a whole lot more to go here. After the 4s, if you look back at that filling order, after the 4s is the 3b. D, keeping in mind that D's are always one number less than the row they're in. So this is the 3D, and we're going to fill that all the way up. How many electrons can fit into a D? A maximum number of 10. So we're already up to 30, so we're almost halfway there. We're getting there. After the 3D, if you look at the filling order, is the 4p, and we're going to fill that all the way up with its 6 electrons. After the 4p is the 5s, and we're going to fill that with 2. After the 5s, we have to go to the 4d. That 4d is going to be filled with its 10 electrons, and then we're going to end up with the 5p6 after that. You can double check your numbers if you want to at this point, but if I go to the 5th row into the p block, into that last position, position number 6, what I'm going to see is that that brings me to the element xenon. That's 54 electrons. I've taken care of 54 total electrons, and I still have just a little bit left to get to my 78. After the 5p is a 6s2, and then after the 6s, you'll notice that the periodic table bumps you down into the F block. F is always 2 less than the row that it's in. So that's why it's the 4f. But I've got to go all the way through the 4f. The 4f only takes me from number 58 cerium all the way over to number 71 lutetium. So to fill that up would require all 14 electrons that can fit into an F. Then that puts me back up into the D block. D's are always one number less than the row they're in, so the 5D. Now this is where platinum is. And if you count over on the periodic table from the beginning of the D block, which is where we would see lanthanum, number 57, and I count over to platinum, platinum is in the 8th position out of 10. Gold would be in the 9th position, mercury would be in the 10th position, so I would be in the 8th position. I would have only 8 electrons left at this point to fit into that 5D. You can always double check yourself by totaling up the number of electrons, which are the superscripts across the top, and you should end up with our 78 electrons at this point.